In this lesson, we're going to be looking at chemical reactions that involve a transfer of electrons. The interesting thing is that we're going to see what happens when the reactants and products are physically separated. A lot of times we think of these reactions as involving just charge from the electrons, but the shift in electrons doesn't have to be complete. We are going to look at oxidation reduction reactions with mostly ionic species, metals and nonmetals, ionic compounds, but it is possible to do that for things that have some covalent bonds. So anyway, when we use the word oxidation number for things that are ionic, it is the same thing as a charge. So if you have a monatomic ion, the charge of the ion is the oxidation number. It's the same thing. And we refer to, when you have these elements that are not charged, they're neutral, we will say they have an oxidation number of 0. And then these others are assigned, and like I said, these can be used if a compound doesn't have ionic bonds. It gives you a way to kind of keep track of where the electrons are shifting, even if there isn't a complete transfer. So let's look at some examples. When we write an oxidation number, we don't write it up here to the right like a charge. An oxidation number goes right above, and it doesn't matter that, you know, for a lot of these it is a charge. Just technically it's supposed to be right above, and let me show you why it's different. So this is the oxidation number because that's the charge. Anytime you have a neutral element, the oxidation number is 0. So for something like this, an ionic compound, we have to think about what charges it has. And chlorine is in the -1 column on the periodic table, so the silver is +1. So once I figure out those charges, those are the charges in this compound. Those are the same thing as the oxidation numbers. For something like this that's covalent, you don't have the charges to go by. So what you do is you use the rule about the element hydrogen on the previous page, and hydrogen is -1, and so what we're going to do is figure out what this has to add up to make it neutral overall. We know that the oxidation numbers for a compound have to add up to 0, so in that case this carbon must be a +4, because 4 times -1 is -4, so this carbon must be a +4. Now I showed you that just so that you know that that does occur. We are not going to do any of these in class like this. We're going to stick to the ones that are ions or neutral, like so. Let's look at how this works in a chemical reaction. So the reactant reduced is gaining electrons. And so if we look, the gaining electrons, I have copper labeled, it's going from +2 to, this is an oxidation number of 0. So the electrons are neutralizing that +2 charge, and so it gained electrons. So how I remember that reduced means gaining electrons is that its oxidation number is reduced. So if I'm trying to spot it, I look at the one that's oxidation number went down. That's how I remember which one is which. And then the reactant oxidized loses electrons. Its oxidation number goes up. And you always have these occurring together. You always have one reactant being reduced and one being oxidized. That's because it's a transfer of electrons. One is giving electrons to the other one. So you always have two reactants and two products, one gaining and one losing. Okay, this is another way of looking at it and assigning these. When we say agent, that means reactant. So the oxidizing agent is the one that is oxidizing the other one. So it is causing the other reactant to be oxidized. The oxidizing agent itself is being reduced in the reaction. It's oxidizing the other one, it itself is being reduced. The word oxidizing agent comes because of oxygen. Oxygen is a great oxidizing agent. You may know, maybe you've seen before, like some plastic that kind of gets whitish and brittle with time, and we say it's oxidized, or maybe a coating, like the clear coat on a car. When it gets too hot and it's older, it gets oxidized, it gets kind of whitish looking. Anyway, we do use that term, and it is because oxygen is a great oxidizing agent. It is causing those other things to be oxidized, and it itself is being reduced. A reducing agent is the one that is the reactant that's causing the other one to be reduced. It itself is oxidized in the reaction. So this is just a matter of perspective, but another term for reducing agent, and you don't have to know this one, but just to kind of make it click, a reducing agent is also an antioxidant. So, we say that like in medicine and biology. An antioxidant is something that reacts with an oxidizing agent and kind of makes it less reactive, basically. It reacts with it so something else doesn't. But anyway, so a reducing agent reacts with an oxidizing agent. Let's practice these terms and assigning oxidation numbers. So let's first start by assigning oxidation numbers. When an element is by itself, its oxidation number is 0. In an ionic compound, we go by what the charges would be. So we're going to look and see what happened to sodium here. Sodium went from 0 to +1. That's oxidizing. And then if we look at the chlorine, it is being reduced. Its oxidation number is going down. Its oxidation number is reduced. So that's how I remember that one, and then I know the other one is oxidized. So 0 to -1 is reduced, therefore I know the other one is being oxidized. We always have one of each. So if you spot one and you're careful, then you know the other. Okay, so what is being oxidized? Well, we already said sodium. And technically it's correct to say, we're not going to say that this sodium is being oxidized, sodium +1. This is being oxidized, the sodium with no charge. What is being reduced? That's where we said the chlorine, and it's going from 0 to -1. So on these, they're switched. So the oxidizing agent is the one that's reducing the other one, so it would be chlorine, and the reducing agent is the one that's oxidizing the other one.